Can you see okay? Not so much. Who? Can you close that blind, please? And maybe Yusra or Lena, actually, you're on the outside. That's a little better. Alright, so let's have a look here. That's a hexagon. So I want all the vectors in terms of A, B, or AF. So here is AB. Or what else did I say? AF. Where's F? Here. Okay, the first one is BC. So BC, I want that in terms of A, B, or AF. Now I think it's helpful if we draw the triangles in here. So I hope, let me call this here X. I hope you can see that if this is 60, this is 60 also. They're all 60. So these two lines are parallel and the same. It's all equilateral triangles. So that means BC is the same as this vector. But from the parallelogram law, you know that BC, this vector here, is AF plus AB. This is like the parallelogram law. You see, you draw the line parallel and you draw the line parallel. So the answer is just AF plus AB. So that's the first one. Now the next one is CX. What's CX here? CX? Well, CX is the same as BA. Yeah? CX is the same as BA, which is equal to minus AB. Okay, what one's next? XD. So XD, what's XD? It's the same as
AB.
Yeah, it's the same as AX, which is the same as BC, which is the same as AF plus AB. I used the first result to help me here. What one's next? AD. What about AD? Yeah, it's 2AX, which is 2AF plus 2AB, if we take the 2 out in, I mean. And then lastly, BE. BE is 2 AF. Okay, so write these down please if you haven't done so. Okay. Okay. You have that? Yeah? I can scroll down? No, people still writing.
When we have an equilateral, it means all the sides are equal or against?
Yep, all sides and angles are equal.
So why don't we just say like BC is equal to AB or AF? Since all of them are equal.
BC is the same as what?
AB or AF.
Well, it's not the same as AF. Which way does BC point?
It's like
Northeast. And which way does AF point? East.
So it's equal to FE.
It'll be equal to FE. Yeah. Okay, next now. So we'll look at the next worksheet now. What's wrong, Yusra? Oh, tell me, what's wrong? It means you were talking about something bad. True? No. That definitely means yes. Okay, position vector. So this is very, very common in the exam. Very common in the exam. So firstly, what do I mean by position vector? So from now on, in each diagram, we will always have some point called O, the origin. So for example here, maybe here's a triangle A, B, C. There's always going to be some point in the diagram called O. What vector is this one here that I'm drawing? What vector is this? AB, yeah. And what's this vector here?
OA.
OA. And this one here? OB, for example. Yeah. Oh, sorry, will we? For goodness sake, Stephen, speak English. In each diagram, we will. Now, in fact, it's not really important where the origin is. We can usually put the origin anywhere. In the exam, they don't draw the origin on the diagram. But that's because it's not important where you draw the origin, actually. Just like in physics, you would know, or in maths, where you put the origin is not important. Like, for example, here, if I say, what is the distance between A and B? Does it really matter where I put the origin? No, it doesn't affect the answer to the question, what's the distance between A and B? So the location of the origin is not important. So if they don't draw O, you can put O anywhere. Okay, so now we need to say what exactly is a position vector. So in this diagram, I've drawn three vectors: OA, OB, and AB in my example. These two are called position vectors. So what do you think makes something a position vector, if you look at my examples?
When it starts from the origin?
Yeah, that's what makes a position vector. A position vector is any vector that just starts at the origin. So that's a position vector. Any vector that starts at the origin O. Often we do not write DO. So what I mean by that is, if I have OA, often we don't even bother to write the O, we just write A. So when you see only one letter, it always means we start at O. So when we see only one letter, it means we start at the origin. You got that? Yeah? Okay. This makes it quite convenient. Can I scroll down, or you need a minute to write this? Just a minute, okay. So now we're looking at problems which are really common in the exam now. Because in the exam they usually deal with position vectors. Not always, just most of the time. Are we ready? Yeah? Yes? Okay. So we're going to have a look at our first rule. So if you remember at the start of this lesson I said AB is not a position vector because it doesn't start at O. But there is a way to make any vector into a position vector. So let's go back to my diagram. A, and let me put here B, and here's O. So, AB, that's not a position vector because it doesn't start at O. We want it as a position vector. We want it to be at O. And there is a way that we can do that. If you watch, if you look here, you can see that AB is the same as AO plus OB. So we can say AB is the same as AO plus OB. That's the same as minus OA plus OB. That's the same as OB minus OA, which is the same as B minus A. So what we have just done is we have changed our AB into two position vectors. We've said that AB is the same as B minus A. So that would be this one and this one. Although it's not too important about that part just yet. This is the important part. This is how we can change non-position vectors into position vectors. And although this formula looks very simple, it is very important. So the vector AB is the same as, if you want, you can think about it like this. The vector AB is the same as B plus minus A, if you want to think about it like that as well. This is called the triangle rule or triangular rule because the diagram looks like a triangle. But it's very important, it's used a lot, it's very useful. I think you will need to use this in nearly every exam. It's not in the formula book, it's too simple. Okay, let's have a look at some examples now. We have this. I can scroll down. So what I'll do is, I'll do the first question here in the book as an example. I'll give you your book back now, Who. There's the origin there. And I'm telling you that this length is the same as this length. And also that this length is 3 times bigger than this length here. So this here is 3 times bigger than this one here. And that this length is the same as this length. This is the information I give you. And I want all answers to be in terms of A and D. And I'm looking to get B, and I'm looking to get C. Okay, I will give you just a minute or two to try it first before I show you. But just to explain what I want the vector B. So where does the vector B start? Oh, so I want the vector OB. I want you to write it using A's and B's. So I'll give you a minute to try and do that. A's and D's. Okay, shouldn't take you too long. What is the answer? B can be written as, very good, minus D. So if you look, here's the answer. B equals OB, which is the exact same thing as DO. OB is the same as DO. They're the same length and the same direction, which is the same as minus OD, which equals minus D. So B equals minus D. Okay, now try please and get me the C. And actually I'll do a third part now in a minute. In a minute, later. Okay, do we have the answer for C? What's C? Minus 1 over 3. Yeah. So C equals OC, which equals 1/3 AO, which equals minus 1/3 OA, which equals minus 1/3 A. Okay, for the last part, I want you to get this vector now from B to C. So I want this vector. B to C. Okay. Do you have this last one?
Yes.
BC. What is it?
Minus
So
D.
is there A
Yep.
minus D?
Not quite. B
D.
plus, yeah. BC is C minus B, which is minus 1/3 A minus D, which is 1/3 minus 1/3 A plus D.
How do we know the direction?
Of what?
For example, we twisted C and D, we changed the sign to break the direction of B and C.
Yeah.
So how do I know where exactly this triangle is going and in what direction?
Well, pick an example for me so I can explain it.
This one.
The last one?
Yes.
Yeah. BC. Starts at B and goes to C.
Okay.
So it should look like this.
What about C?
Okay, so when we start to go like B, O, and then O, C?
Yeah, if you want to do it this way, it would be from B to O and then O to C.
I can't do it the other way around.
No, if you did it the other way around, then what you would be doing is CB, or in other words, minus BC. Your sign would be wrong.
You can say minus OB plus OC. It's the same as C minus D, right?
Oh, hold on there. Minus OB,
Plus OC.
OC, that's the same as C minus B, which is the same as BC.
Yeah.
Yeah. Yes.
The first answer will be I can have A minus D plus 1/3A.
No, I want all my answers now in terms of A and D.
The minus D plus 1/3A.
So again, minus D?
Plus 1/3A.
No, you have the sign backwards. It sounds like you did what she did. The sign's the wrong way, yeah. What you gave me, Abraham, would be minus BC. Okay. Let's see now. Yeah, no, I think that's okay. That's okay. So as you can see now, they're starting to get a little bit more difficult. You know, it's not quite as straightforward. You have to think about it a bit more. Let's have a look at the diagrams here. Okay. Just to be clear maybe on just some notation, just so you're completely clear. If you look for example at number 2, when I do those little arrows in the middle, I'm saying OX is parallel to ZY. You see that? And those little ticks on WM and MY, they're equal lengths. Yeah.
And so OZ and XY are OC.
And also OZ and XY are parallel. Now, yeah, actually that's good. Just be careful. I'm not saying OZ and XY are the same length, although they are. Those arrows mean they are parallel. And the ticks, the dash, means they're same length. Okay? So just be careful about that. Here. These lines are parallel, so I draw this on them to show they're parallel, but are they the same length? No. These lines are not parallel, but they are the same length, so I show that with ticks, like this. So just please be careful about that in the exam as well. Just because two lines are parallel, if these are vectors, are these the same vector? No, because this one is longer. But if lines are parallel, if this vector is A, this could be something like 2A maybe. So if vectors are parallel, at least you can know that it's some number multiplied by A, if they're parallel. And in this case here, they're not parallel, so they're completely different. If a question asks you to check if two lines are parallel, it's asking you to check if the first one is A and if the second one is some number multiplied by A. That means I know that they're parallel. So parallel vectors are vectors which are just a multiple of another vector. So for example, here is east and here is 2 meters east. These are parallel. This is east and this is 2 east. You get what I'm saying, parallel? Yeah? Okay, I'll let you try these for a few minutes. Make sure you practice them, okay? So just try them for the last 10 minutes.